You want to learn how to create a smart contract for an NFT marketplace? Welcome to this tutorial. Today I'll be showing you step by step how to create a Solidity smart contract for an NFT marketplace. So with no further ado, let's quickly jump into the video and start creating that smart contract. But if you see a huge problem, or if you want to talk about something, just drop that in the comment section below and we'll discuss about that. So with no further ado, let's quickly go through it. We are here in our command line. So what we're going to do is to create a new next app, because we're going to create the Solidity part on the front end. So I'll start by saying npx create next. It's not a React app, but next app, and I'm going to call this Cyrus Market. Okay, Cyrus Market, just like this. So this is going to take a couple of seconds, so let's wait for it to get done or to finish so that we can proceed. Yeah, so this is done. The next process, or what you're going to do next, is to navigate in that folder. So I'll say cd Cyrus Market, just like this. Okay, and now since you're in the folder, I'm going to open that using this command, and I'll open that in VS Code. So let's just wait a couple of seconds while VS Code is launching. All right, so let's just wait for it. In the meantime, I'll be enabling VS Code right here so that we don't waste time. Okay, so let's just wait for it. A minute, and I don't know. Yep, you can see my VS Code right now. So here, this is our folder, and this is where we're going to work. Okay, so right now you can see a simple next app or a simple next.js app, but now we want now to integrate we want to integrate the Solidity aspect of the project. So for that, we'll go back to our terminal, and right here we are going to install hard hat, and we'll say npm install hard hat, just like this. So this will also take a couple of seconds. Yeah, it won't take so long to install. Just wait for it till it gets done. Then apart from hard hat, we're also going to install a couple of dependencies that go with hard hat, or to facilitate our development process. Okay, so while that is downloading, I'll just go back right here to VS Code, okay, and walk you through the project. Okay, so as a next.js app, everything will happen inside of pages. Okay, and then inside of API, that's where the backend is. Okay, or the backend is located. As you can see, this is a simple backend, but we're not going to go into that. For us, we are going to work right here, app.js, where this is the beginning of the application. Then we have index.js, where we have our application located. Then this is the part that we are going to integrate with Web3, or the Web3 aspect, or integrate it with the blockchain. Okay, so while waiting for hard hat to finish, I'm going to show you where you can get the rest of the dependencies that we are going to work with. Okay, and for that, you will just need to go to your browser, and yeah, you will see this right here, and it's sorry, and this is hard hat, the hard hat official docs. So these are the dependencies that you are going to install after hard hat. Yeah, we have here we're going to have a hard hat Wefo, Ethereum Wefo, Chai for testing. Okay, and Ether is this is the API that will be talking to the blockchain from inside our next.js application. So we're going to install those dependencies. You can just copy this whole line. Okay, and that will be, we're going to put that into our command line and install that when hard hat is done installing. Okay, so let's wait for hard hat to get done with the installation so that we can continue. All right, that's done. It was pretty quick. So here we're going to copy this and install. It's going to take a couple of seconds, so I'll see you when it gets done installing, or when the installation is done. Okay, as you can see, that is downloading. Okay, so it's somehow messed up. Let me clear it. We are going to install one more dependency. Okay, and you're going to say npm a the open zeppelin. We're going to install the open zeppelin contract or boilerplate. Okay, so that you can get the NFT. I think it's, yeah, I think it's that open zeppelin / contract. Okay, so because we are going to use some ready to use contracts or some ready to use boilerplates, okay, we are going to use the ERC721. we are going to use ERC721 URI storage and counters. Okay, and those are already implemented by OpenZeppelin, so we don't have to redo the same process one more time. So we'll just we'll just get them and use them. Okay, so that's done. Now let's go back and start developing our project. Okay, so right here we're going to, as you can see, our project is, I mean, it's a simple project up to now. Then we're going to create some folders from our command line. What we're going to do here is to generate the folders that will contain our solidity code using the command line. So what you're going to do here, is to type npx hard hat. Okay, just like that. You type enter and just wait for it to finish the execution, and you'll see some files or some folders have been created in our project. So just give it a second, because it's generating those pages, all those folders. Or maybe let me go back to VS Code so that you can see live what I'm talking about. Okay, so just give me a second, give it a second, sorry, while it's downloading or while it's generating those files. But before we reach there, let's go back to our command line, because there are some commands or something we have to accept. So we are going to create a basic sample project. You just need to type enter. Hard hat project root, yes, enter. You want to add a git ignore, yes, enter. Okay, so they're telling us you need to install these. I mean, we install these dependencies, but the project requires those, I mean, these specific versions. As you can see, they have specified some versions there. So we're going to copy that and paste and wait for that to finish downloading. So while we're waiting for that, we can still go back and see that, I mean, and see the new folders that have been created. So if I go back to VS Code, as you can see, we have now 3 green folders on file. So this is, I mean, let's start from contract. Okay, contract has a default file, greater sol. So this is the solidity code containing there, but we are going to create our own solidity code, so this doesn't matter. Okay, then we have scripts, and these scripts are some piece of code that help us deploy our project, or that help us deploy our smart contract. And we have some tests to help us to test our code, of course. So we're going to do some simple testing, okay, so that you can have an idea of how you can test your smart contract. Then later on you can add more and more tests to your smart contract. So here we have our configuration. Okay, this is our hard hat configuration. So here we can add maybe the test net where we want to deploy our contract. Maybe if you want to deploy on Mumbai, if you want to deploy, I don't know which test net you want, or maybe on the main net. This is where we're going to have our deployment, I mean our private key or private account, and we are going to specify on which blockchain we want to deploy our project. But since there is no blockchain specified, that means we are going to deploy it locally on our node. Okay, we are going to spin up a node on our computer. Okay, so let me just, okay, let's check if that is done downloading. And yeah, that's done downloading, and now we are ready to go, right? So let's go back to VS Code, and first thing first, we are going to start by deleting. As I said, we are going to try to, I don't know if I can call it refractor, but that's what we're going to do. And this one, I'm going to just rename it. Instead of deleting it, I'll rename it, and this is going to be nft.sol. okay, because this is where we're going to create our NFT. Okay, so I'm going to delete everything here, and I'll leave these two lines of code. Okay, so I'll just create another one, and I'll call this market, because this is where all our stuffs will happen. Okay, and it's called market.sol. So I'll just come and copy this. I copy to save sometimes and paste it here. Okay, so these are the two files that we are going to mainly work in. Okay, so apart from that, I'll have my script for deployment, and what I'm going to do here for now, I'll just rename this. Okay, for easy deployment, I'll just call it deploy.js, and all these stuffs we are going to work on them. The rest can stay like that for now. So let's go back here to nft.sol and start doing what we are supposed to do inside of that specific folder, okay, or that specific file. So now what I'm going to do, first thing first, I'm going to download, or I'm going to link all the repositories that I want, or I'm going to link all the files that I want. So to start off with this, I'll just put in my erc721.sol. I'll put in my erc721 URL storage and counters.sol. okay, because we want to increment the count whenever one NFT is being minted. Okay, so now I'll put them all at once, so just give me a second. All right, it's right here in NFT here. So I'll just put them all. And remember, we downloaded the open_zeppelin/contract dependency, so you just need to add token /erc721 and such stuffs. But if you're wondering where we are picking all those from, you can just go on GitHub and look for OpenZeppelin, and you'll see this open_zeppelin/contract. So the way I'm saying is that you can come here and then you go on /contract/token. okay, we are trying to look for the erc721. it's right here. Then erc721.sol, it's right here. So this is the contract we are using. But you don't want to recreate all this because it has been recreated by OpenZeppelin. Okay, and same for the other ones. So that's why we install the dependency, and now we are picking just the project, or we are picking the file that we want. Okay, so in our case we have picked this file, and this other file. Now let's create our smart contract and start by writing contract, and this contract will be called NFT. Okay, I want to call it NFT. So in the contract called NFT, what we are going to do is to start by initializing our variables. Okay, so the variables we are going to initialize in this case, let me just reset my mic. Right, so what we are going to initialize in this case is that we are going to initialize the counters. Okay, and apart from the counters, we're also going to initialize the address. Okay, so let me do that quickly, and I'm going to say using counters, using counters for counters.counters, and this counters is coming from OpenZeppelin and in the utilities of OpenZeppelin. Okay, so next I'm going to now initiate the variable that will store that. Okay, because the counter.counters, it's just sort of a library that helps us in Solidity to increment a value. Okay, and get the value incremented or decreasing the value, such stuffs. Right, so now I'm also going to have an address, and I'll call it contract address. Okay, so yeah, I'm going to call it contract address. Those are the variables that you're going to have. And now what I'm going to do is to have a constructor. And what is a constructor? Basically, a constructor is a function that executes only once, and it only executes when we are creating, when we are deploying our smart contract. And don't worry, if you see those lines kind of auto-completing, that is GitHub Copilot. All right. I just want to flex my GitHub Copilot a little bit, but I think I also make a video about GitHub Copilot in the future, and my impression about GitHub Copilot. All right, so that's not the topic for today. Let's continue. Now here in the constructor, we're going to receive an address, and this address is going to be called marketplace, okay, because it's going to be the address of the marketplace. So don't get confused about these stuffs. You're going to see how to use it, okay? So we're also going to say here ERC. Oh, sorry, before we implement this, we are going to inherit, okay? We're going to do some inheritance. So we're going to say this is ERC 721 URI storage, okay? So now down here, I'm going to say ERC, yeah, it's ERC 721, and I'm going to give it a name. Oh, sorry, ERC 721, and we're going to give it a name, and this gets the name. I'm going to say Cyrus token, okay? That's how I want to call it, and you can auto name it, and you can name it however you want. It's up to you to name it, and the symbol will be CIT, just like this, okay? So now what I'm going to do next is to open the curly brackets and close them. So the next step, we're going to say here that this address, contract address, okay, that we initiated should be equal to marketplace. Okay, so I'm just going to say marketplace address, because you have to name them according to what they are or what they do. So I'm going to say marketplace address, just like this. So that's how it's supposed to be, and you don't have to forget the comma. But GitHub Copilot has reminded me. Yeah, I think GitHub Copilot is kind of cool, right? Anyway, let's continue with what we are trying to do. So next step, I'm going to say function set token. I'm going to call it set token, just like that. And this set token will be taking a string, okay, and that string will be called Token Uri, okay, and we are going to be receiving that from the front end. And basically, what will be the string that we'll be receiving? It will be the string pointing to where our NFT is located or where our NFT is stored. So maybe, for example, if we store our NFT on Pinata will bring back a UID, and that UID is the one that will be attached to the NFT on the blockchain so that it can be recovered easily, okay? That way we have to expect a token URL from the front end, and this will be a public. It's going to be a public function that returns something, and the something that will be returned is going to be a uint. And remember, since Solidity is a statically typed language, you have to set everything at the beginning, or you have to how can I say that? You have to set the type at the beginning, what is being returned, what is being stored, and such stuffs. So here, first thing first, we are going to say token IDs dot increment. We are going to increment that, and as you can see again, my GitHub Copilot has come to action, but it seems that there is an error here that says has to be memory. Yeah, and that's true, because this has to be in memory. So that means it will expire after the function is done executing. Yeah, let's first leave that for the moment. So next step, what you're going to do is to set a new item, okay? So the ID of the new item we have first incremented. So here I'm going to say item ID, okay, and this is going to be equal to token ID, token IDs dot current. Okay, so what you're doing there, basically, first of all, we're incrementing the token IDs because it basically starts on 0, so we are incrementing that, it's becoming 1, then we are getting the current value. That means item ID in this case will be 1 because that's the value we are getting, okay, after incrementing. So after doing that, the next step, we are going now to mint that token. We are going to say safe mint. This will be safe mint, and as you can see, no, but forget about GitHub Copilot for now. Sometimes it messes up, so you have to be very careful. But what you're going to do here is to say message sender. Okay, so we are minting the token to the message sender, the person calling that function, and what we are minting to the message sender is the item ID, and that's all. Forget about GitHub Copilot. So here, oh sorry, yeah, as I was saying, you always have to put commas there, not comma, but you have to put sorry, my GitHub Copilot has started complicating me. Yeah, that's how it's supposed to be. So as I was saying, after each line of code you have to put a semicolon. So next step, I'm going to set, yeah, it's called set token URI. Yeah, and as you can see, set token URI takes in an item ID and the token URI. So we are going to just do this, and this token URI is coming from right here, and item ID is this ID. So first of all, you are attaching the ID to the message sender. Okay, so he holds the NFT. Then after doing that, next step, you attach the URI, or you attach the metadata to that NFT. Okay, I think it kind of links up. All right, so after doing that, you have to return that, of course. So we are going to return our item ID. Yeah, for real, GitHub Copilot can speed up your process. So I think we are done in this particular file. Okay, because we have created all the logic for creating an NFT, the logic of how do I say it? Yeah, the logic of creating that. So now we are going to go to our marketplace and start minting our NFTs, selling the NFTs, listing the NFTs, you know, all those stuffs. But before that, let's get right here. I don't know what's bringing an error right here, but we're going to fix that. Increment equal, and guys, I always want to leave this part where I mess up. I want to leave them in my recordings so that they can help someone else who is stuck, because most of the tutorials out there, you don't see where the person is stuck, okay, and you don't know how they debug and such stuffs. But I always want to keep them there so that you guys can see that, oh, we also get stuck, okay. We all get stuck at some point. So just give me a second, let's double check. Yeah, this is all right. Token IDs, all right, but the errors oh, see, the errors that I've put two closing curly brackets at the same time, yet I had expected one. So we see here set token URI, this has to be underscore set token URI, so that it becomes the set token URI from Open Zeppelin, okay, because all those we are getting them from Open Zeppelin. And as you can see, the error has disappeared already, and yeah, we are moving forward. We are one step forward. Yeah, guys, at this point you should be proud of yourselves. Okay, so now what we are going to continue, and in the market, okay, I'm also going to import some ready to use contracts so that we speed up the process. Okay, so I'm going to come here and paste them right here, so you can pause this video and see and look at them and see where we get them from. Okay, then after that, we're going to create another contract, and we're going to call this market.sol. no, not .sol, just market. Okay, I'm kind of messing up. Yeah, so that will be our market, and that where everything is going to happen. Okay, that way we're going to manipulate our NFT the way we want to manipulate it. Okay, so first thing first, I'm just going to inherit again, and here we are doing the Reentrancy Guard, and you can read more about the Reentrancy Guard in your own free time. But basically what it does, it avoids how can I say it? It avoids an outside contract to re-inject inside of this contract when it's not yet done executing. Yeah, and I think this has been implemented after the 2016 DAO hack that I think some hackers stole 150 million dollars from a certain DAO because of that issue. So now the Reentrancy Guard has been implemented since then. So let's move forward. In your own time you can research about that. Okay, so we are still going to use the counters. So I'm just going to copy that using counters from counters. You remember that because we did it here in nft.sol. It's this same thing that we are reusing right here. So next step, apart from that, we're going to create an owner. Okay, and basically the owner will be the address. Okay, the owner will be the address of this smart contract, the smart contract of this whole marketplace. So this is going to be an address, and going to be a payable address. And why do I say it's going to be a payable address? Because you can send ether to a payable address. Okay, you can send ether to the payable address. And why are we going to send ether to this address? Because we have to pay the listing fee. Okay, so that's just normal, and that's how you do it. So I'm also going to set the listing fee, of course, and this is going to be a uint listing fee. Okay, listing fee, and this is going to be equal to maybe 0. Since this is going to be deployed on Polygon, okay, this is going to be deployed on Polygon, so that means we are going to use Matic. Okay, but I'm going to say 0.1 Matic, but remember, for now I put Ether, but remember that Polygon and Ether, they are two cryptocurrencies that have the same decimal places. Okay, and now this will act as Matic when we do, when we deploy that, or when we pay, this will act like Matic. But we only say Ether because Polygon is a layer 2 scaling solution that is based on Ethereum, yet on Ethereum we use Ether. Okay, so I think if you have ever read about that, you understand what I'm talking about. If not, you can make some research about the topic, and you'll get everything about that. So after doing that, after setting that fee, the next step that we are going to do is to have a constructor. Okay, and basically we are going to say constructor, and remember, as I said, this constructor is a function that executes only once when we are deploying our smart contract. So when we are deploying our smart contract, what do we want to do? We want to say the owner. Okay, we'll say the owner will be the person who will deploy the smart contract. So the message sender, the person deploying the smart contract, will be the owner of that. So all the listing fees will be going to that same address. Okay, so after doing that, after setting the constructor, the next step that we're going to do, let me just see. Oh, this, of course, this has to bring an error because it has to be a payable address. We specified it right here that it has to be a payable address. So you can't put there a normal address because we specified. Okay, it's statically typed, so you have to specify everything in advance. All right, so after doing that, I'm now going to create an item. Okay, so we're going to use a struct, that means a structure, and that will be an item. Okay, this, and my GitHub Copilot is trying to give me an item, but I'm going to ignore that item for the moment and have my own new item. All right, so the item will have it's going to have an item ID. Okay, we are going to have an item ID. So the second the second one, we are going to have the contract. Okay, the contract where that NFT belongs to. So I'll say address NFT contract, just like this. Okay, a third step, we are going to have another uint. Okay, uint, and this will be the token ID. Yeah, and the token, basically item ID is the place of that item in the array of elements, but the token ID is coming from right here, nft.sol. You can see the token ID will be this item ID. All right, so don't get confused about token ID and item ID. So we are going to have an address, and this address will be a payable address, payable, and this is going to be the owner. Okay, the person owning that NFT. And why do we say this has to be payable address? Because when someone else is buying the NFT, of course some money has to go to the owner of the NFT. All right, so we're also going to have the price of the NFT, of course, and we're going to have another boolean that will tell us whether the item is sold or the item is not sold. Okay, and we're going to, oh it's on sale or not. Okay, so we're also going to have that boolean. If the item is on sale, it's going to be displayed on the NFT marketplace. If the item is not on sale, it's going to only be displayed in my profile or on my profile. Okay, and basically that's how it's going to work in this case. So after structuring the item, next step, we are going now to create a mapping. Okay, and basically which type of mapping are we creating, or why are we creating a mapping? We are creating a mapping because we want to know all the items. Okay, all the items that are in our, how can I say, in our marketplace. Okay, and now we want to know the ID. Remember up here, let me just go back there. Yeah, we have item ID, so we are going to know, oh, this item ID contains this structure or this item. Okay, so that's what we're going to implement. We're going to say this is going to be equal to a uint that will be pointing to a struct. Yeah, I think, yeah, it's going to be a uint that will be pointing to a struct. So instead of struct, it's going to just be item. Okay, and now this is going to be, let me say, this is going to be a private one, and we're going to call it maybe market items. Yeah, something like that. So this will be market item underscore IDs. Okay, because we want to know the IDs, but you can name it however you want, but for now that's the name I've found that I could name that way. Okay, so after doing that, of course we're going to have another function, and this first function will be mint NFT. Okay, because we want our users to be able to mint their NFTs. So right here, yes, again you can see my GitHub Copilot is trying to suggest something, but unfortunately I won't use that. I want to create that from scratch, if I'm, yeah, sort of saying. So this will be expecting an address, and this address is going to be called NFT contract. Okay, apart from that, we're going to have a uint that will be token ID, of course. So we're going to also have another uint that will be the price. Yeah, that will be the price. So I'm going to have uint price. Okay, and this should be a public function, and it depends on, you can call it external public, but I just want to call it public. So this is going to be a public function, but sorry, let me just, according to the convention, these should have underscore because they are, I mean, to differentiate them with other variables. Okay, so you just put some underscore in front of each one, but you not, I mean, it's not a must that you have to do that, but it's a good practice to do that. Okay, so we are going to have, this function is a public function, and since we are going to send ether No, we are not sending ether right here, but we want this to be non-reentrant. Okay, and what does non-reentrant means? Remember I told you about the reentrancy attack, so we want this to not be called twice when it's still executing, because execution on the blockchain, they take time. So we want it to finish before any other smart contract or any other function can call this one. So that's the purpose of non-reentrant. So next step, what you're going to do, we're going to have two conditions. Okay, and conditions sorry, and conditions in this case should be wrapped around require. So we're going to say require XYZ, and if not, throw this error. Yeah, so in this case we're going to require that this price here should be greater than 0, and that's normal, right? You can't mint an NFT and give it a price of 0. I mean, it doesn't make sense. You want to sell your NFT, then you're going to sell it with 0matic. It doesn't make sense. That's why we don't want someone to mint their NFT like that, or maybe by mistake, mistake happened. So we want to prevent that. So our next step I'm going to say is to increment the number again, so the way we did it. So I'm going to have underscore items, yeah, dot increment. Okay, just like that. So now the first time it's going to, this item IDs is going to be 0. So when we reach this place here, we first increment that. That means it's going to be 1. Okay, so from 1 we can store that. Okay, I think it makes sense. So where do we store that? We store that in market items IDs. So now I'm going to say market item IDs at the position, okay, at the position of item IDs, okay, of item IDs, like that. That means at the position that we get, that I don't know how to explain that, but I mean, I'm just too excited about this. That's why we increment the item IDs, right? So they go from 0 to 1. So at position 1 we store that new NFT created. Okay, all that new item created. I hope you understand that the way I understand it. So before we do that, let me just say maybe this is going to become item ID. Okay, and this is going to be equal to underscore item IDs dot current. Okay, we'll get the current item IDs, and that will replace it here. So this will be item ID, just like that. Okay, and that is going to be equal, oh, GitHub Copilot again. All right, that's good. So what you're going to have here is to have item ID at the beginning, NFT contract, okay, because we have defined that right here, NFT contract, token ID, message sender, okay, that's the owner, but it's throwing an error because it has to be payable. So that means you're going to add the payable right here, just like this. Okay, the error has disappeared. We have price and we have on sale. That way we have created a new item. As simple as that. That new item has been minted, and we are done. At that point we are done. Okay, after creating that, you can mint your NFT safely. Okay, after checking that the price is greater than 0, you can mint your NFT. So after minting your NFT, of course you have to have a new way of selling. I mean, someone has to have a new way of buying your product, or of buying your NFT. That's why we are going to have function buy NFT. So we have mint NFT, also we have buy NFT. Okay, that's a new function. And now when you are buying a new NFT, what you need to have is the NFT contract, the contract where that NFT is located. Okay, we are going to have NFT contract, and second you're going to have the item ID. Okay, the place of that NFT in the list of items that are in that marketplace. So this is going to be item ID. Okay, this is going to be item, item ID, just like this. And this is a public function and is a payable function, okay, because we are going to send some ether to that one. So what we are going to do here is to start by getting that project, okay. I think, yeah, it makes sense that we start by getting that NFT that we are trying to sell, right? So I'm first going to do this uint price, okay. The price is going to be equal because the NFT will be stored right here, okay. And as you can see, GitHub Copilot has discovered that market item IDs right here, okay, at the position of item ID, because we position the item ID here, then you get the price. Because up until this point, let me remove price. When we reach here, we already have all this information, so you just need to access the price inside there, okay. After accessing the price, we are going also to access the token ID. I hope you understand. The token ID is not the item ID. The token ID comes from right here, okay, when we minted the token, not the metadata. So I'm going to have uint token ID. It's also going to be equal to marketplace. Yeah, GitHub Copilot is with me. Yeah, it's really a copilot, okay. We are piloting this we are piloting this build with my copilot, GitHub Copilot. It's somehow funny. All right, so after doing that, we are now going to check that the price, okay, the price that the person buying is trying to send is the same price that the buyer is asking for, okay. So if I'm asking, sorry, let me just set the require. Yeah, so what do I mean by this? If I'm asking for 10 matic, then you send 8 matic, I have to be able, or my contract has to be able to refuse that, okay, because yes, it's a price, but I'm not asking for that price. That's the logic we are trying to put here. So all I'm going to say here is to say require, and I'll require the message value because I'll send that as a message value. I'll require message value to be equal to price, okay, the price of that specific item. If that's not if that's not the case, yeah, again, GitHub Copilot has warned you. You must pay the price of the item, Yeah, it's kind of hard, but yeah, you have to pay the price of the item. Of course, you don't want to get the item for the price that the seller did not ask for. Okay, so after doing that, next step, we're going to say market items.id.owner. Okay, the owner of that, it's right here, the owner of that item. We send him the value, okay, the price that he asked for. We say, this is your money, give me the NFT, okay. So after doing that, we are going again to change. Of course, we are going to transfer the NFT. Okay, we are going to transfer the NFT from me to the person, okay, and this is going to be just right here, from address, from message sender, okay, because he's the person who has given me money. So we'll go from the person who gave me money to, no, not from the person who gave me money, but from me, okay. And me, where am I located? Yeah, I'm right here, market item blah 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 dot owner. So the former owner is sending the NFT to the message sender who has paid money, so that he becomes the new owner, okay. So after sending that person the NFT, or after changing the owner of the NFT, I want to set him as a new owner, and his address has to be a payable address, so that when another person buys the NFT, this person can get some ether or some polygon or some matic, sorry, or whatever you want, okay. So after buying the piece, of course, you have to say, no, my piece is no longer on sale, okay. I've bought it, I'm putting it in my, I'm putting it in my wallet, and it's not on sale, okay. So that later on we're going to implement a function. If you want to sell, okay, if you want to sell your NFT, This has to be uppercase. If you want to sell your NFT, you can change this from false to true so that it appears on the list of NFTs that are on sale. Okay, I think that kind of makes sense. Okay, so now after all that, okay, you have received your money, you have received your NFT. Next step, you now need to pay the platform where you have listed your NFT. So we are going to have the owner, okay, this owner up here, the one who deployed the contract. He's the owner, and we send him his listing price, and this is listing fee, not listing price. We send him his listing fee that he said my listing fee is equal to 0.1, either Ether or Matic. So in our case, it's going to be Matic because we'd like to deploy this to Polygon. So we're going to send him 0.1 Matic and he will be happy. Okay, I'm just joking. So next step, after doing that, we're going to implement the function that will allow us to put our product on sale, or to put our NFT on sale, right? Remember right here, after someone has bought an NFT, it's not going to be on sale anymore. So we're going to have another function. Maybe when that person wants to sell his digital art, he has to put it on sale again. So here the function will be list for sale. Okay, and this will of course take the address of the NFT, and that address will be called NFT contract again, NFT contract. So it's also going to get a uint that will be token ID, and it has to be uppercase, underscore, and we're also going to have item ID. Okay, I hope now you get the difference between token ID and item ID. So why do we want to have both of them? I'll explain that in a second. So let me just do this. So now here's the reason why we want to have both of them, is because we are going to get that item ID, okay, and change the on sale to true, but we are going to send that NFT to the marketplace or not. What do I mean here? It depends on what you want to build. You can either require the token ID because you will send that from your wallet to the marketplace, or you can change. But let's see if we change, if it's going to work. Okay, and what do I mean? If I don't send my NFT to the marketplace, I stay with it, but I list it on sale. Let's try that. Let's have fun. I've never tried it before, but let's try that together. So in this case, I'm going to remove my token ID. Okay, I don't know if it's going to work, but we are trying this together, right? You guys have agreed, right? Maybe you're going to watch, even if you're going to watch the video after, I assume that you have agreed. Let's see where it goes. Okay, and that's the coolest part with development. So we're going to again get this from market IDs, and again my Copilot. Guys, I think you should get GitHub Copilot. I'm enjoying it a lot. So I think I'm also going to remove this because it's of no use in this case. Okay, so that's the function to list it from for sale, because we're going to say on sale equals now to true. Okay, now after doing that, we are going to have two other functions. We're going to have a function to fetch all the NFTs, okay, that are on sale. That means all the NFTs that we can list for sale, or that are listed for sale. And we're also going to have to fetch all the NFTs that are my NFTs that will appear in my profile. Even if they are on sale, even if they are not on sale, they will appear on my profile so that I know how many NFTs do I own. Okay, so let's quickly do that, and I'm going to create another function, and this function is going to be called function fetch NFTs. Okay, and this fetch NFTs, it won't take any parameters, and it will be a public function. Of course, it will return, it has to return something, and returns, it's going to return market item, a list of items, right? And this is how you say returns list of item, just like that. So that one will return the items, okay? And I think that has to be a storage or memory, something like that. Let me see. Yeah, location must be memory. Yeah, that's true. They are true. So after putting location to memory, it should resolve that bug, okay? And then next step, we are going to fetch the NFTs, right? And to fetch the NFTs, we're going to have the count. We're going to say item count. Item counts will be equal to, is my GitHub Copilot right? I don't know, but I'll figure it out. Yeah, item count. Item count is equal to 0. Then next step, we're going to have the current index. Yeah, uint current index is going to be equal to 0. Yeah, that means up here we're going to have our items. Yeah, you know, you just need to guide it a little bit and you're there. We're going to have items id.current to know the number of items in our overall marketplace, and also we're going to have the current index because our new array has to start from 0. That's why we're going to have the current index. And then we're going to create a list of items. So it's going to be here. We're going to create a list of items, not market items. That was supposed to be market items ID. So we're going to have an array of items, and this is going to be equal to new market, yeah, new item, and the number is going to be item count. Okay, that will be the array. That will be the length of the array that we expect when we are fetching the NFTs, of course. So next step, I'm going to create a for loop, okay, to loop through all that. So I'm going to have for uint, yeah, uint I equals 0. Then boom, already have Copilot again. So we're going to have uint equals 0, and this should be strictly less than item count, and we're going to increment that. So now when you're doing that, you have to say if the market items IDs dot on sale. So if true, if on sale, we are going to do what? We are going to say items. We are going to say items dot current index equals market item IDs at that index. What do we mean? This is an array of items that are on sale, and this is the array of items of all the items, right? So that means we're going to say the market item at this E, okay? So that will be the market item at the position where the condition is true, is going to be equal to a new place, okay? Current index will be the index of that item in our new array, or in the array of elements which are on sale. That way we initialize this to 0. Then after that, we are going to increment it, or we are going to increase it. I don't know if that's clear or not, but I think it's clear. So after doing all that, we'll have to return items, of course, because we said this has to return something. And I'm seeing kind of an error here. Function state mutability can be restricted to view. Yeah, I think they're right. We're not changing anything to the blockchain, so this can be view, because you are not changing anything on the blockchain. So after doing that, the next step that we're going to do is now to fetch my own NFTs, because this is done. So now I'm going to say fetch my NFTs. My sorry, this has to be my NFTs, and this is a function, and this is a function called fetch my NFTs. I do this, and it's going to be public. This will also be view, and it will return arrays. Oh, GitHub Copilot. Let's see what GitHub Copilot tells us. So this will return an array of items from memory. So we're going to have item count will be again to current, as the same as up here. But I think GitHub Copilot has messed up. It has repeated this same code. But no worry, we're going to change that code to what we need. Okay, so I'm going to have item count and current index. So we have item count, we have current index. So the next one that you're going to have is going to be called, how should we call that? I think we're going to call it total items. I don't know. Yeah, let's give it the name. Let me just delete this lie this lie of GitHub Copilot, but I'm going to have here total items. Okay, total of my items, and by default is going to be 0. So after that we're going to have a for loop. Okay, and basically I think we'll have 2 loops. Let me just put the first loop. So here we're going to say this is not total item count, it's total items. Okay, so what you're saying here is that sorry, and that total items shouldn't be 0. I think I'm getting something wrong. Yeah, oh, I understand. This one has to come down here. Okay, and then this 0 is the one that coming here, because this item count is the number of items that are ours. Okay, but this is the total of items just. Okay, and this will be the current index in our newly created array. That will be the array of our items. Yeah, that's how it's supposed to be. I think it makes sense. Okay, and now here you're going to say if the market items dot owner is equal to the person calling this function, that means they own that NFT. Okay, we're going to increment our count, and this will count all the NFTs where we are the owner. I don't know if that makes sense. Okay, so that for loop will create the NFTs, all the NFTs that we own. So after doing that, the next step will be to create a new item, right? No, a new array. And this is going to be our array, and it's going to be an array of items from memory, just like that. Okay, what does this array? This will be the array of items, and the length of that array will come from here. Remember, we are incrementing the count, so that means the number of items where we are the owner, that will be the length of the array. Yeah, I think that makes sense. I don't know about you, but yeah, according to me it makes sense. So after doing that, we are going to have to loop again, and in this case we are going to loop because we need that item. Okay, we need to put that item, each item at the right index in our new array. So yeah, I don't know if you understand, but that's how it's supposed to be. So let's just loop very quick, and this we have to change it. It's item, it's not market item. Just give me a second. This is supposed to be item. I think I'm kind of messing up with all these stuffs. And this is total item, total items, not total count, total items, just like this. And yeah, this is market.ids that we are getting from up there. I don't know if you can remember. We are getting that from up there, and those are all the element of our marketplace. Okay, not all the elements of this new array, but all the elements in marketplace, the ones that are sold, the ones that are on sale, the ones that are not on sale, mixing them together. All right, so this is going to be market item dot underscore IDs, and that should work. So we're getting an error here. This this is still an error because we are not returning anything. Okay, so here I'm going to say return items, and that items array is this new array that we created right here. That will be the array of all the NFTs that we own, okay, even if they're on sale or not, but we own them because no one has bought them, okay. So all those NFTs are going to come back to us and be displayed in our profile. And after doing this, we still have an error here because we have to put a semicolon, and as you can see, everything is green at this point. So that was a lot to cover. Okay, so what you are going to do is to go again through it all. So we initiated the item IDs and the counters. We gave the listing fee a constructor so that we get the owner of the person deploying this contract is going to be the owner. We had a structure that stored how our item is going, which element are going to be in our item. We had a map called market item IDs, and that will be, it's going to be a key value pair, that where the key is a number and the pair is the item at that number, and that number we're going to call it item ID. Okay, so we had a function to mint, we had a function to buy, we had a function to list for sale, to fetch all the NFTs that are on sale, and fetch all the NFTs of a certain address. Okay, and that address will be the message sender address. Then we go back here, we have a token ID that will be assigned to the person minting that token. Okay, and after there we're going to increment this so that whenever a new NFT is created, it's completely unique, because NFT stands for non-fungible token, so it has to be one and unique. That's why we keep on incrementing every time. So with that said, guys, our marketplace is ready. Okay, the solidity part or the backend part is ready. Now it's time to test that and deploy that. Okay, so our first step that we're going to do is to get out of here, and now we're going to focus on the scripts. Okay, and as you can see, we have so many comments here. Let me remove some of them, remove some of these ones. Okay, just like that. So now, instead of wasting time, I think we're going to change just this, and we're going to first deploy the market, because the address of the market has to be passed in the address, in the construct of the NFT. You see here in NFT, we have marketplace address in the constructor. So we have to place this marketplace address. We have to get the marketplace address before we deploy the NFT itself. Okay, so we won't say market, we get this from market, just as simple as that. Okay, so we deploy this. I hope you guys are seeing. This is just to save some time. We're going to have const market. One market is uppercase, another one is lowercase, so don't get confused. Okay, so this is going to be market, just like that. Don't deploy. Then this also will change. Market, not mallet. Market dot deployed. So the market has been deployed, and after that market has been deployed, that means we can access where it has been deployed. Okay, then we go to the next phase, is deploying the NFT. Okay, so I'm going to have const NFT is going to be equal to await GitHub Copilot. Thank you. So our next step, you're going to have now NFT. I like GitHub Copilot. Okay, so what you're doing here is redoing these same steps. Okay, because we are deploying two different contracts. Okay, so now here's the trick. If you deploy this like this, it's going to refuse. Yeah, this one will deploy, the market will deploy, but the NFT will not deploy, because here on deployment, the NFT expects a parameter, and the parameter is going to be the address of the market. Okay, so this is what you're going to do. You say market dot address. Okay, so that you get the address of the market, to know that NFT is associated to which marketplace. Okay, or to which solidity part of the marketplace. So now after doing that, what you're going to do next is, oh, let me just remove this, it's the one creating the error. So what you're going to do next is to console log. Okay, here I'm going to say market deployed to market.address. Then if I got the next line, I'm sure my GitHub Copilot will come into hand. Oh, Copilot, then, oh, Copilot does not disappoint. Okay, so now when we deploy this contract, you are going to see these two console log. So if you see these two console log, that means this has been deployed. And if maybe you are deploying on Polygon, that address that you'll get, you can go on maybe Etherscan. I don't know if for Polygon it's called Polyscan or Polygon Scan. You can go there and see that it has been really deployed. But in this case, we are still deploying on a local node, so the node that is running on our computer. And in my case, I've not yet spinned up a node. So next step, let's just spin up a new node so that you can see how this is done. Okay, so to spin up a new node, I'm going to say npx hard hat, okay, node. Then you click enter. You're going to see 20 accounts being displayed right there. So just give it a second, wait for it. You'll see those accounts deployed right there. But deployment takes time, so you bear with me that we're going to stay here for some seconds, you know, to just see how that goes. Okay, or just give it a minute. It's going to get done very quickly, so that, oh, my bad, does not showing. I was not showing what I was doing. So this is what I did. Okay, just this, simply npx hard hat node, and clicked enter. So that is spinning up my new local local blockchain, okay, where I'm going to deploy my contract. And the good thing with hard hat is that hard hat itself gives you 20 accounts, and each account has 1000 ether that you can use just for practice. Okay, that's not really real ether, it's just the ether that you use to practice. All right, so let's just wait for that. It's taking long. I don't know why it's taking long. Oh, right, it's now up. So these are the 20 accounts, and as you can see, each account has 1000 ether. Yeah, 10,000 ether, and this is just ether of practice. And by default, when we're going to deploy, we will use the ether of this first account. So that's how it works. Whenever you do some deployment, it uses ether of the first account. So without wasting time, let's go ahead and deploy our project. Okay, let's go and deploy our project. So I've spin up another, don't get confused guys, I've opened another command line, but I cannot throw that into my OBS right now. That's why you cannot see it. But I've spin up another node, and on this terminal I'm going to just show you the commands that I will use, okay, to deploy my contract. But I've already spinned up another local blockchain. That's why I'm going to quit this one. Okay, so don't get confused. Let me just quit this one, because on this one I'm going to show the commands of how to deploy an NFT contract or a solidity contract. Okay, so just give me a second. Okay, let's go ahead. What you're going to do here, first thing first, okay, is to type in npx hard hat run scripts /deploy.js, and that's the file containing our script for deploying. Okay, but now if we were deploying on a remote network, like maybe let's say maybe on Mumbai, we were going to add here network, like to specify network to Mumbai. But since we are still on our local blockchain, you don't need to specify that. You can simply, after typing script/deployed.js, you can simply click enter and wait for it. Okay guys, I'm going to show you this part so that you see how it compiles and all those stuffs. So as you can see, it's saying compiling 14 files. And yeah, you might ask yourself, why are we having 14 files yet we only have 2 files? And remember what I said before, it's because we have our open zeppelin, okay, open zeppelin contracts that we are using, okay, like we use the erc721.sol, and those contracts have to also be compiled because they are like ready to use contracts, so we don't need to rewrite them, but we use them from the open zeppelin GitHub repository. So when we are launching or when we are deploying, we have to recompile them. And yeah, as you can see right there in my terminal, we have marketplace, okay, market deployed to this address and NFT deployed to this address. So now if we were maybe deploying on Mumbai on the Polygon testnet, you can pick this address right here, go and put it on the Etherscan or on the Polygon scan, and you can see that the contract has been deployed. Okay, but right now we're still doing everything locally. That means we can't put that anywhere, but that shows that our contracts have been deployed on our local blockchain. And yeah guys, congratulations, that's a huge milestone. You have to clap for yourself. Just give me a minute. Yeah, I have to clap for yourself guys. That's a huge milestone. So next step, we're going to test this contract, okay, and basically we're going to write a simple test. We're going to test it, and you can add other tests, but I'm just going to create a simple test, then we move forward. All right, so right now let's jump in and write some tests. Okay, so for this I'm going to go back to my Visual Studio Code. Okay, it's right there. So what I'm going to do is to come here to test, okay, and we have sample/test.js. So this is how our test looks like, okay, but I'm going to delete all this, okay, and start afresh. So our test, how is our test going to be? First of all, we're going to use chai, okay, as you can see there. We're going to use chai for testing. So we're going to test the overall application instead of testing bits of the application. So you can also test like that, but to speed up this whole process and to make the video a little bit shorter, we're going to create the test for the overall application. Okay, so right here in sample, this is what you're going to do. I want to say describe, okay, just a minute or a second. We are going right here and we say describe the way it's like that, NFT market, okay, and instead of NFT market, we can just say describe market, okay, to make it easy. I'm going to say describe market, not to make it easy, but to make it match with the rest. And inside here we're going to say it. So what should it be? We're going to describe what it should do, okay, not what it should be, but what it should do, okay. And in this case, it should create and execute marketplace sales, right? I think that's the overall application use. Then we're going to have a function. So which function should be executed against that, how can I say, against that check, right? And this is going to be an async function because we are going to talk to the blockchain. This is going to be an async function, and inside of this function we are going to write some code to execute. All right, and first thing first, I want to get that market, okay, the market contract that we're going to test against, or I don't know how I should call that. Is it testing against or testing with? I don't know, but anyway, we're going to first deploy it. So to deploy it, we are going to follow the same steps as deploying, okay. and I'm going to say marketref.deployed GitHub Copilot is with me. Okay, still with me. Okay, but you have to be careful with GitHub Copilot because sometimes it makes some, you know, some unwanted mistake or some silly mistakes. So but anyway, let's continue, and we are going to await this. Then we get the address. So we are going to get the address, no, not NFT address, but market address. Okay, and the market address is going to be equal to market.address, just like that. So here, instead of saying market.address, we are going to insert the market address, just like that. Okay, so continuing down here, so we are done deploying the market. We are now deploying the NFT itself, and we get the address also. Okay, so the deployment is done, and you can take this one step further and compare maybe and say that the address shouldn't be empty, so that you be at least sure that, you know, your contract has been deployed. Okay, but we're not going to do this because, as I said, this is just you know, it's just a simple illustration. Okay, so now let me just get the listing fee. Okay, let listing fee going to be equal to 0.1. okay, so I say here listing fee is going to be equal to listing fee dot to string. I want to change this to a string. Okay, because when I change, when I convert this to ether, the parse ether method will require me to have a string. Okay, and you understand that in a little bit. Okay, so now our next step, we are going to create our token. Okay, we're going to mint some token, and let me just go back to nft.sol and see how did I call that function. Okay, it's called set token. Okay, the function is called set token, and I'm going to say await in sample right here. I'm going to say here await NFT, yeah, because it's in the NFT dot create token, and this will take some, you know, random metadata, and I'm just going to put in some random metadata as expected. Okay, it can't refuse so don't be afraid to put fake data there because it can't refuse. So I'm going to create this twice. Okay, Control C, put it here, my token 2. Okay, my token 2, this is my token 1. Okay, just some dummy data so that we can mint that. All right, so next step, what I'm going to do here is now to, so yeah, await market. Now we are going to mint the NFT. I hope you understand that two steps. Create token is coming from nft.sol. Set to, oh, it's set token, not create token. Sorry, my bad. It's set token right here. Also, it's called set token, just like that. So let me also double check if this is mint. Okay, just to be sure, you know. Yeah, mint NFT. Yeah, mint NFT. So now, which values does, or which parameters does this expect? The NFT contract. Okay, in this case it's going to be NFT address. Yeah, NFT address. We are also going to have the token ID. So we're going to have 1 because this token ID will be 1 and this will be 2. So now we're going to have the item ID, I'm sure. Yeah, the next is let me see. Yeah, to mint an NFT, you will need just an NFT contract, token ID, and the price of your NFT. Yeah, the price, I'm going to say oh no, yeah, let me just sell that for, you know, let me sell it for 10 matic. So that's the first mint. So I'll just copy this, because remember there are 2 tokens, so I'll have to mint them all. And this is going to be also 2. This is going to be 2 right here, and I'll sell this for 100 Matic, okay? And in this case, since we are still on our local blockchain, it's going to be 100 ether, and this one 10 ether. Wow, if I sell an NFT for 100 ether, I might get rich. Yeah. Just joking. Okay, so after doing that, okay, we are going to have the next step. The next step is going to get the address that will mint. At this point, the address that will mint, it's going to be the first address. Remember that 20 address I showed you? So the address that will mint these tokens, right here, these 2 tokens, is going to be the first address. So now after doing that, I'm going to have another step. Okay, so what I'm going to do here is now to try to sell. Okay, I'm not going to try to sell an NFT, you know. I just want to get some money. Don't blame me. Okay, so I'm going to do this. Okay, so now this line of code, we are trying to get the signers, the address that will sign and will sign a contract. Will sign a function. Okay, that is cryptography, part of cryptography. So you have to have an address that will sign the transaction. Okay, so you might ask yourself, why did I put underscore then buyer address? That's because the first address that comes when you get the signers is the first address, and remember, the first address is the one that deployed the contract. So you can't sell something to yourself. I think you understand it that way. So that's why I got the second address, which is the address that did not do anything. Yeah, I hope you understand that part, and it's crucial to understand that part. So after doing that, I'm going to now do something else. Okay, I'm going to do something else, is to sell, okay, or to list. To sell or to list, it depends on what you want, but that's what I'm going to do. I'm going to try to sell 1 NFT. Okay, so to do this, I'm going to just come right here, and I'll have to connect the market, and wow, this is what I want. This is GitHub Copilot. We have buy NFT, so let's double check if Copilot is right. NFT contract and item ID. Yeah, we have NFT address, item ID. So GitHub Copilot wants us to sell our first NFT. Okay, so we won't need listing fee, by the way. So GitHub Copilot, you have so many things to change. Okay, but up until this point, everything is kind of working very well and coming into place. So let me double check. I'm seeing an error, but I don't know where it's coming from. Oh, we should have a closing. Yeah, that was the error. So after doing that, okay, we have it right there. We have bought the NFT. Then after buying the NFT, we now want, okay, listen to me, we now want to check something else. Okay, and what do we want to check is to check if the number of items are going to be equal to 2, because we have minted 2 NFTs, so the number of all the items has to be 2. I don't know if you understand what I mean right there. Okay, so just let me show you that, so that we can add at least, you know, another feature in our test. So we're going to have items, we get all the items. Did we call it fetch market items or fetch NFTs? It's not fetch market items, but it's called fetch NFTs. Is that how I wrote it? I don't know. Yeah, that's how I wrote it, fetch NFTs. So after fetching the NFTs, I'm going to say expect. Is it expect? Yeah, I think it expect. But you know, this is what GitHub Copilot is, you know, is telling us to do, but I don't want that. Okay, I just want to say the length of these items dot length. Okay, this should be equal to 2, because we have minted 2 NFTs. so the length should be equal to 2. Now it's time to test that. This is the most scaring part of this whole process, but anyway, we're going to go with it. We go back right here. Now to test, we just need to say npx hard hat, okay, test, and you click enter. Let's wait for it. Testing is always, so it's always cumbersome, so I don't know what will happen there, but let's give it a shot. Oops, right, we have an error. Our test did not succeed, but the error is saying reverted to the reason you must pay for the price of the item. Okay, that's great, let's just see. You must pay the price of the item. So when you're buying, oh yeah, they're right here. You should add value, okay, and this value should be equal to ethers.utils. Is that how it's supposed to be? Yeah, ethers.utils.parse ether, just like this, and this should be a string. Okay, so the value that I'm sending, let me see. When I minted this, I said it should be sent, it should be bought for 10 ether. Yeah, then here I pass ether 10. Okay, let's retry this. Oh, my bad, I was not showing the changes I made. Sorry. Yeah, this is what I did right here. I added this one, okay, the value that has to be sent, it has to be 10 ether, because if you remember, when you are buying an NFT, they're checking if the message value is equal to the price that they require. And I think right now that's what we have done right here, where message value, this is going to be the value, it's going to be the ether of 10. That means 10 ether, but in big number. So let's try that and see if it works. We'll redo the test one more time. Okay, again, npx hard hat test. Oops, let's wait, the moment of truth. But anyway, let's see how it goes. Okay, we get an error. Value must be a string. Okay, I understand. So here I should turn this into a string, so I'm going to say string 10 and see again how it goes. Let me just clear my let me clear right here CLS, then I'll say again npx hard hat test. Boom, we retry it one more time. Let's see. Okay, you must pay the price of the item. Anyway, let's just double check together. So the first item, it's right here, and I'm sending 10. I think I should do the same here. Ethers.utils.parse ether of string 10. So let's make sure we are doing the same thing. Okay, then yeah, let's retry that and see how it goes, right? So I was not again showing, so right here you see the way I did it here, it's the same way I've done it here. Maybe when this is being converted into a big number, it's kind of changing. So let's retry the test. We'll retry the test, npx hard hat test. Click enter and wait for it a minute while the test is being conducted. Okay, we are now getting a different error saying transfer caller is not owner nor approved. Okay, and this is happening at line 42. All right, let's go back and check market line 42 and see what's going on there. Market line 42. Yeah, my market is here, line 42. Oh, okay, to message sender, blah blah blah. All right, so let's fix that. I think I'm going to first go back to nft.sol, and here I'll set approval. Okay, I want to give that right to my, not the message sender, but I want to give this right to my address. Okay, and which address am I giving that right? I think it should be address this, because address this will mean the contract. So I'm giving access to my contract. I think, let me think about it for a moment. I give access to my own guys, these stuff somehow they're complicated, but you bear with me that it has to be solidity. So this has to be my contract address, yeah, because that's the address of the marketplace. Yeah, so contract address, contract address. I don't know why this is refusing. Maybe I misspelled something. So let me just hover here and I see 2 arguments given but expected 3. Oh, that's kind of strange. Oh, I understand. This is not supposed to have an underscore. Yeah, the one that has an underscore is another one. So again, let's retry this test for another time. Okay, npx. I think this is why so many developers hate testing, right? I don't know, but let's retry it. npx hard test, click enter. Yeah, wait for it, compiling. Hope the test passes. I'm not sure, but we'll see. Wait for it. It's taking long. Oh, the test has failed. Okay, what are they saying? Function called failed to execute. Okay, but they're not providing any useful error on why that has failed, but we'll try to figure it out. We'll try to figure this out. And it's failing at buy NFT line 45. Okay, let's see what is at line 45. It's right here, market sold line 45. Okay, it's saying payable to owner dot transfer listing fee. Where's the listing fee coming from? Listing fee is right here. So this is refusing to send. I don't know why, but for some reason it's refusing to send the money. Let's see what could be the error here. What could be the error? Why money is refusing to be sent? I think we should look at let me see. Let's go back to Visual Studio Code, and it's on buy NFT line 45. Okay, let's try to remove this payable. Okay, let's just remove that for a second, so it becomes owner to transfer. Yeah, we transfer him the listing fee. So let's retry that. npx hard test. Oh, I'm not showing my yeah, I'm sure I'm not showing. Yeah, okay, now we're good to go. So npx hard test. Let's try again another time. Wait for it, because it has to compile, deploy, and then make that test, you know, because we said it has to deploy. So again, let's wait and see how it goes, you know. It might accept this time. Okay, it has failed one more time in function called failed to execute. I don't know why it's I don't know why it has failed to execute, but yeah, let's double check one more time. So I think we'll go back to our Visual Studio Code and look again into this function of buying, because it seems that it's the function causing a problem. Okay, you must pay, yeah, then you transfer the message value. Okay, for buying an NFT, you transfer the message value, and next step, this one, safe transfer from. Okay, you transfer that also. You pay you change the owner, you list for sale, then listing fee. Yeah, listing fee is 0.1 ether. Okay, then let me see. It's by NFT. Then for the owner, you transfer. Let me just see if we say maybe we transfer the message value. Okay, let's try that. Let's try that and see how it goes. Let me just change. Go back to the command line. Try to npx hard hat run. Okay, no, it's test. We are testing. Let's wait for it and see. I don't know what's the error there, but let's try to see if this will work. So just a second. Wait for it. No, it has refused. I don't know why, because even the function is a payable function. So right here, the function is it's a payable, public payable by NFT. So I think this is the transfer method is the one causing a problem. Okay, transfer message value, but the owner is right here. It's an address, payable address, owner, message sender. So owner.transfer, this is the line causing the problem, because if I remove this line and I try to do the test again, the test I think will pass. So let's do the text again, npx hard hat test. When you enter, wait for it. Second, it's compiling and deploying, so we will have to wait. So in the meantime, I don't know, guys, I think I should start live streaming, so that at least in a live stream someone will tell me, oh, this is the error. Yeah, as I was saying, you can see that is working. The test has passed. Okay, should create and execute marketplace sales, one passing. So this test has passed. So let's go back again to Visual Studio Code and double check one more time. We are having this. Yeah, this is passing this part. So we are transferring message value, and then yeah, I understand, guys. So now here, this is the value that has to be split between the owner and the owner of the owner of the market, because the owner of the market and the owner of the product. So if we send the whole value to this one person, this one will not get the listing fee. So to get around this, it should be message value minus listing fee, because the listing fee will go to the owner of the platform. Okay, and now this person has to get his value minus the listing fee. So if we retry this one more time, I'm sure this will work now. So npx hard hat test, finger crossed, let's see. So wait a second while this is running. Wait for it. it has to compile. It's compiling the files. Now it's running. Let's wait for it a minute. Yeah, I was right. Now, as you can see, everything is displaying and the test has passed. You say should create and execute marketplace, one test passing. Okay, and these are the 2 minted NFTs. So guys, yeah, that's it. We are done basically with the solidity part. Our test has passed. That means everything is working just fat. So let's deploy the contract. We're going to stay here, and now I'm going to say npx hard hat. Okay, and this is going to be run scripts /deploy.js. so when I hit enter, let's wait for it. Yeah, now we are deploying. We are done testing. We can now deploy. Okay, so now we got the 2 addresses, one address for the market, one address for the NFT. Now it's time to go and work on the front end. So yeah, technically we are done building our smart contract, testing it and deploying that. So the next step, you can either deploy that on a testnet like Mumbai if you want, and you can also create the front end part of your smart contract so that you can get the front end side of the Web3 application. But if you want me to create another tutorial about how to build a front end for a decentralized application, just drop that in the comment section below and I'll create a step-by-step guide on how to do that. So guys, thanks again for watching, and I'll catch up with you in the next tutorial.